Welcome back. Today, we enter one of the most transformative centuries in human history, a time when the entire way we think about life shifted completely. We're going to see something almost unbelievable. In just 150 years, Western science moves from explanations based on purpose, divinity, and vital forces to explanations based on laws, mechanics, mathematics, and experiments. So, in Lecture 1, we talk about the meat, and Lecture 2 was the first rational curiosity. This lecture is the moment curiosity becomes method, measurement, and evidence. So, I also need to warn you this lecture includes some dramatic stories involving excommunication, imprisonment, public burning, telescopes causing scandals, and mistaken ideas about aliens. So, a great time to grab a coffee and join me. So, let's go. What changed during the scientific revolution? Scientific revolution wasn't a single event. It was a cascade of inventions, books, arguments, telescopes, microscopes, and personalities that created a new worldview. Three key changes shaped the origin of life debate at this point. Observation replaced tradition. People stop relying on ancient texts and start relying on experiments. Mathematics becomes the language of the nature. Suddenly, the universe looks quantifiable, predictable. Nature becomes mechanistic, not mystical, not purposeful, not drive driven, but a system of moving parts governed by laws. This is the intellectual atmosphere in which modern biology and science is born. And there were a lot of influences in everyday life of people like Renaissance and Reform movements took place. So let's talk about the decline of theology and vitalism. So for thousands of years, people believed life exists because God wills it. Nature behaves for a purpose. Living beings contain a special vital force. After 1600s, these ideas crumble. Why? Because once you see the Jupiter's moon through a telescope and the bacteria through a microscope, you can't pretend the universe is simply a stage for human drama anymore. Nature becomes an object to study, not a message to interpret. So, one of the first figures we will talk about, which one I would say very important, and even the father of modern astrobiology, is Giordano Bruno. So, let me introduce this boldest and most tragic thinkers in the story of astrobiology. The man who said, there are numberless suns and countless earths circling around them. The universe is infinite. Other worlds may have life. This is the first person in recorded Western history to explicitly claim that stars are suns with their own planets, what we now call exoplanets. Bruno wasn't a scientist in a modern sense. He was a philosopher, a mystic, and also occasionally a troublemaker. But his vision was astonishing. He imagined something almost identical to modern astronomy 400 years before the first exoplanet was even discovered. The tragic part, in 1600 the Inquisition executed him, not specifically for believing in aliens, but for a long list of theological challenges. Still, Bruno stands today as a symbol, the first martyr of cosmic thinking, the spiritual father of astrobiology. So if you ever look at an exoplanet catalog and feel awe, remember that Bruno did it with no telescope, just imagination. And then we will move into one of the other important figures, Francis Bacon. So Francis Bacon is the father of the scientific method. So he actually write the code of how to make a science, the steps, the hypotheses, theories, and observations. So he's basically the one who said enough with metaphysics and let's actually test things. He introduced the induction, experimentation, empirical data, the idea that knowledge must be built from the ground up, not inherited from the authority. He didn't do biology himself, but he gave us the tool set that made biology possible. Every laboratory experiment you do today, even something as simple as label your tubes, has Bacon's fingerprints on it. Without Bacon, there wouldn't be microbiology, chemistry, origin of life, astrobiology, or science as we know it. But this doesn't make his way a dogma. So if you're familiar with Karl Popper, a philosopher, um, and he really think about the education philosophy, and he's not a fan of Francis Bacon's ideas, and he has very incredible papers if you want to read about it. It's Karl Popper, and he talk about the way of science in pre-Socratic period was making more sense rather than making all observation. Maybe a little imagination and curiosity might help as well. So I would really um, would suggest you look after the Karl Popper as well. He won't be in the slides, but yeah, let's continue to Descartes, the body as a machine. So, of course, he's famous for cogito ergo sum, which interpreted as I think, therefore I am, but he actually meant I doubt, therefore I am. But his impact on biology is even more interesting. He said animals are machines, body is a machine, life functions can be explained mechanically. By the way, let's just go back for a second to Francis Bacon. Um, do you know how Francis Bacon died? Which is a really interesting story. He caught pneumonia while testing whether snow could preserve meat. He literally died doing a badly designed experiment for the sake of science, the guy who designed how to make an experiment. But yeah, let's continue Descartes. I'm sorry, I just had that fact in mind. So, for Descartes, life becomes mechanical. Heart was a pump, body is hydraulics, nerves were tubes, carried animal spirits, reflexes were mechanical reactions. There is no vital force needed, it's just a machine. And this is revolutionary. He was trying to turn biology into physics in a sense, but this idea is actually pretty strong because, in a sense, our body work like a machine of different cell making tissues with different um, different reflexes and actions and how they answer certain situations work really like a machine. Even though many of his biological ideas were wrong, like there are spirits in the blood veins, still he did something very crucial. He separated mind from body and allowed the body to study it scientifically. Imagine the cultural shock at the time, saying animals aren't animated by a soul but by mechanics, like robots. In 1650, he was borderline heresy. He was compared the human body to mechanical fountains at Versailles, full of pipes, pressure, and automatic responses. It was the first crude analogy for physiology. He had a very strong influence because he also worked and interested in physiology and talked with many doctors at the time, and in his writings he really explained anatomy very clearly. And let's get to Galileo, the telescope, and the shock of the new worlds. So we are introduced the telescope to the science world at this point. It's one of the few scientists whose story feels like really a movie. He invents a telescope, actually improves a Dutch design, and points it at the sky, and suddenly Jupiter has moons, Venus has phases, the moon has mountains, the sun has spots. The universe is not perfect. This breaks the Aristotelian cosmos idea, and there's a astrobiological related moment. If Jupiter has four moons, maybe those moons have worlds, and maybe those worlds have life. Galilei himself speculated about this, though his idea was limited. The imagination it unlocked was huge. So his biggest contribution, he showed that observation beats authority. So when Galileo seen these moons of Jupiter, and he showed them to clergy members, some refused to look through the telescope because they believed the instrument itself is influenced by the devil and might be deceiving their senses. But let's move to another giant, Isaac Newton. So Newton's work is the moment humanity realizes that the universe runs on universal laws. His laws of motion and gravity don't just describe falling apples, they describe the galaxies and planets and comets and cosmos itself. And if the universe is governed by universal laws, life must also follow universal principles. Newton didn't directly work on biology, but he made scientists believe that biology could be explained, not mystified. After Newton, nature looked solvable. Also, a story that not many people knows. Newton once stuck a needle between his eyeball and the bone behind it to study how pressing the eye alters vision. So scientific curiosity was really different back then. So we came to Herschel and Huygens, very interesting people and very related to astrobiology actually. So this is where things get a bit fun. Even brilliant scientists allowed their imaginations to run wild at this point. There's William Herschel. He discovered um, Uranus, built gigantic telescopes, believed, and he observed the moon and saw the craters and the shapes on the moon. And these lunar craters he thought was cities built by lunarians. And he wasn't joking, he genuinely thought the moon was inhabited, which was really interesting. So he observing the moon and reflecting a level on a subject that all those small circuses we see on the moon are the works of lunarians and maybe called their towns. And he was actually observing the asteroid craters on the moon, and the craters seemed almost perfectly circular. So much so they couldn't have been possibly been formed by natural processes in his case, and they must be worked of an intelligence. So he really believed that moon had habitants and who were constructing these on the moon. And let's move on to another interesting figure who is Christian Huygens. So he was a famous astronomer who discovered Titan, Saturn's largest moon, invented and improved telescopes, wrote a book claiming the inhabitants of Jupiter and Venus experience music and culture, which we will talk about. So he observed the spots on Venus, Mars, and Jupiter. So these were the features of storms and deserts, and on the surface of Mars as well. And he concluded that the clouds and water and it felt the taste of music with the inhabitants of Venus and Jupiter at high level, similar to Italians, let's say. Now, today, this seems crazy for us. Earth has life, so other planets probably do too, he said. And these ideas were wrong, of course, but they did something important. They established established the expectation that life might exist elsewhere. But the lesson we might get from this is when you have limited data, then the conclusions becomes maximal imagination, and this works as a way where you have more data and imagination falling down and you are getting closer to the truth, and this really shows it. uh, so let's talk about the other most important findings at the time. Rather than telescope, there's a microscope. So two figures here, Robert Hooke and Leeuwenhoek, which were really important, and I now think many of you are familiar with them. So Robert Hooke draws, um, he found the cell and named the cell, basically. Um, he saw the microorganism, but thinks they are really simple. And in 1670s, Leeuwenhoek built ultra-precise lenses and discovers the bacteria, protozoa, and sperm cells. Become the first person to see microbial life in history is Antoine van Leeuwenhoek. So this had huge impacts. For the first time, humanity realizes life is microscopic, complex, and everywhere. Spontaneous generation might be false. Vitalism begins to crack. So Leeuwenhoek ruined the idea that life is simple. He showed that even the smallest organism is more complex than anyone imagined. So Leeuwenhoek actually kept his lens making technique a secret his whole life. And modern researchers still struggle to reproduce his optical quality. It's really wonderful and interesting. So technology drives biology. Now we switch from telescope to microscope, and scientific revolution gives us tools, finally reveal the hidden world of microorganisms, visualization methods, and improved lenses for all. Um, Before this, people had no idea bacteria existed. They had never seen a cell, so this changed everything. And let's continue. Let's talk about the mechanistic biology Descartes introduced and with vitalism. Scientific revolution set the stage for battle that lasts 200 years and even 200 years more now from now. So in mechanistic biology, in this new view that scientists introduced, life becomes a chemistry and physics and no special, nothing special in essence or vital spark, just matter that obeys the natural laws. In old view, the vitalism we called life contains something non-material. There is a vital force, not reducible to chemistry. Both sides had brilliant scientists, actually. So this conflict shaped the next chapters of biology, especially in origin of life debates. So this period is really important. As you can see, I put a Venice here because actually during the Renaissance she was the first figure that drawn naked and not related to theological ideas, which is groundbreaking. And you also see the uh, Martin Luther here from the Reform movement. So this period has many different sides to it, of course. So everything we study in origin of life research, from chemical evolution to protocells to RNA world to extremophiles, is only possible because of the scientific revolution period. This period gives us empirical testing. It replaced the dogma with experiments, invented microscopes, made biology measurable, and introduced mechanistic physiology. Unified physics, astronomy, laid the foundations for chemistry. This is the intellectual soil in which modern astrobiology grows, and many, many influential figures here. So, in the next lecture, we move directly into the end of spontaneous generation idea, end of vitalism, Pasteur's experiments, the rise of microbiology, and the beginning of actual chemical models for life's origin. This is where the story gets experimental and where modern abiogenesis truly begins. And thank you, and I'll see you in lecture 4.